Right, so we have a talk today about DevOps, but first I will do a quick introduction about Q42. Q42 in a nutshell. So who are we? We are 90 engineers, more than 90 engineers, working on various projects for companies within the Netherlands or outside. So think about PostNL or HEMA or Fitch in this case. This is one of our ships. So where are we located? So we are obviously here in Amsterdam. Well, we have a swing. We also have a slide in the back, so feel free to check it out. We also have an office in the Hague. It's near Moorburg, for everyone. You know it. That's our main headquarters. So we have a smaller office. That's the big office. So what do? This is the quote we have. It's in Dutch, I will translate. Q42 builds digital products that improve the lives of people to make it smarter, better, and more fun. So for what company do we work for? So European Sweeper, HEMA, we work for Lightyear, Philips Hue, the Rijksmuseum, PostNL, Efteling, Museum, and Bot, so it's a handful of projects that we did and we're still doing. So one of the big projects we do is for the Rijksmuseum. We built their website, but we also make really nice visual tours. So this is the Johannes Vermeer tour, which was a case a few months back. And with the tour that we built, we won a Webby Award. We're really proud of it and hope to make some new fun cases in the future with the Rijks as well. So some other projects we do is PostNL, the Dutch Postal Service. So with this app you can send your package, track the packages that are sent to you, see postal locations, etc. And track the post. Also you can pick up your packets if you're in the neighborhood of the machine. They put the package in. So it's one of them. It's like one of those we have in the app. We also do HEMA. It's a Dutch retail brand. It's almost 100 years old. In a few years. And we built the app for that. So I think this is like still the old screen. We're currently in a visual identity upgrade. So if you have the app installed, look out for it. These are the projects, but next to projects we also have a few ventures. So 50% of our time goes to ventures, and one of them is Hack the Planet. Hack the Planet is part of a company that we try to improve the world as well. So what do we do? So one of them is fix environmental challenges. So maybe some of you saw the TED talk of Thijs, I think. He did about elephants in Gabon, I think. Was it in Gabon? Yeah. To scare them away from the villages of the people that are located there, so they don't eat their crops. But we also do like social issues. So What the Fuck was a project they did for a company here in the Netherlands. Softworld, yeah. And it's about abuse. So hopefully with this tool, people feel that it's not the thing that they only them encounter, but also the tool. So that's one of our ventures. Then another venture is Meteo. So this is the tool we use to create these beautiful Johannes Vermeer environments. So these are a handful of things you can make with that. So you have the Holocaust Museum, Holocaust Monument in the US, Rijksmuseum, and some more. There are a lot of them, a lot of cases on the website as well, so check out Meteo. And we also do some fun things. So besides the project we do, We also have the boot camp, which is up in next week. So we had a lot of nice pitches for this year. So I'm joining the call center simulator. I think we have like Pixel Perfect, like a really big screen that's going to make RGB lighting based on music. So it's going to be fun. So during the weekend we have 32 hours to build the ideas we have. Kind of like a jumpstart that we sometimes also do. And then in the end we present it to our colleagues. So this is Joost, he's one of and he built the Orgel Bay 2 years ago already. It's an instrument based on toothbrushes that if they vibrate faster they make a higher pitch, and if they vibrate slower then it's a lower pitch. And they made an instrument out of it. So yeah, we have some crazy ideas here at Cube. So hopefully you have like a bit of an insight into what we do. And so we do a lot of serious stuff, but we also do a lot of fun stuff. I think that's the main takeaway. But then the main event, so why are we here today? So we're going to talk about DevOps today, and I would like to welcome Marion to take you with you with a tour of DevOps in Philippines.
Yeah, I will do this presentation together with Wesley. Yeah, this is about what we do for DevOps at Philips Hue. Some might say the best project we do. I think we're a bit biased here, the one standing up here. What we want to talk about today is first go through a bit of what exactly do we build for you, where are we involved in this product. Actually, let me first ask a question. Who here has Philips Hue lights? A couple? Who here knows, or who here doesn't know what Hue is? Nobody. Yeah, that's good. So we'll talk a bit on how we manage our infrastructure through code, how we use GitOps to keep our clusters in sync. And then lastly, I will tell a bit about how we actually make sure it works on production, because that's an important part. So first of all, a little bit about ourselves. I'm Marion Hill. I'm a DevOps engineer at Philips Hue. We don't really do titles here, so this is the best we came up with. I'm a team lead, DevOps engineer, SRE guy, whatever. Leslie?
And I'm Wesley Klop. I'm also a DevOps engineer on the Philips Hue team for like almost 2 years now, I think. Yeah, something like that. Yeah, that's it.
Cool. So let's talk about Philips Hue. So it's one of the first smart lighting products that that came to market, and Q42 has actually been working for them since the very beginning. The first product started shipping in, let's take a look notes, 2012. So over 10 years we have been working for Philips Hue, and then mostly on the cloud side of it. So we have a lot running. We have a large legacy, or a lot of a legacy in there. And I think a couple of years ago there was a nice tweet by the Internet of Shit that said how many servers could it take to turn on a light bulb, with a nice slide of our architecture. So who here thinks this is pretty complex? Sort of bit. Well, actually, the real architecture looks a little bit more like this. Yeah, so we have a lot of services. It's a very complex system, and we manage that with a small amount of people. So the uCloud is built by 2 teams here at Q42, having anywhere between 3 and 6 developers. So I think currently, somebody just asked it, so I did a mental count. We have 7 developers working actively on this system. But we're not only responsible for developing it, we're also responsible for making sure it works, and the whole operations part.
Is it safe to say these are lightweight services?
Nice.
Nice. Well, it depends how you look at it. But yeah, so there's not a lot of developers working on it, and we have a lot of legacy and a lot to maintain. So we've been doing DevOps for a long time to basically get the system in a nice state. So the question, of course, is what do we actually build? Because Philips Hue is a large product, and at Q42 we don't do everything. So Signify is the company behind Philips Hue. It used to be Philips Lighting, and they also do a lot for it. So here at Q42, we built a lighting and account cloud. So what does that consist of? So first of all is the account portal. So this is a website and everything behind the website to manage your system. So the Hue system exists or contains a Hue bridge, which is connected to the cloud, and we do everything for that. So we do the account portal to manage your system, your account, everything related to that. The remote API. So the remote API allows you to turn off and on your lights from outside of your home. And then we do some eventing, which makes sure that if you use something like Google Home, for example, Google actually knows what's going on in your with your lights in your home. So when you open Google Home app, it shows the active or the current state of your lighting system. That's what the eventing part is for. So let's now take a quick gander in the infrastructure. So I showed you the large slide with everything. But let's start with a very simplified view of it, to just get a general idea about how stuff flows. So you have accounts and you have lights and bridges. The accounts talk to Auth0. So Auth0 is our identity provider. That's what we use to authenticate users. And then both the account and your lights, or more specifically the bridge, talks to our load balancer, to Cloud Load Balancer, which talks to Kubernetes. So we run everything in Kubernetes, or almost everything. For everything I say, there's probably an exception somewhere. That's what happens when you build something for over 12 years. And we use the Google Cloud Data Store for storing our data and the system state. We use Argo CD to keep our Kubernetes clusters in sync, and that gets pulled from GitHub. So we use GitHub for repositories and also to know what's in our clusters. Wesley will tell a bit more about how that all works. Are there any questions about this? Is it pretty clear to people? Cool. So what do we actually build? Well, on that slide, there were supposed to be 22 services. I'm not sure. The architecture overview is something we make every now and then it gets out of date. Basically, by the time you make it, it's out of date. But last I checked, we have 22 services. So those are actually managing or making sure the system works. And we have 63 deployments. So next to the services that provides basically the functionality of the system, we have a lot of extra deployments that make sure everything runs correctly. And we have 2 Kubernetes clusters on production. So we have a multi-cluster setup, and we have that on 4 environments. So that's a lot to manage, and all of this receives over 24,000 requests a second. Yeah, there's a lot of traffic going through our clusters and through our infrastructure, which is what makes this an exciting project. Yeah. And you want to tell something about how we manage this actually?
Yeah. Can I take over the phone?
Yes.
Okay, so I just press on
Yes.
Okay, then go to next. Cool. So as you've seen, we have a lot of infrastructure. It's undoable to keep this, to manage this by hand. one of the problems we as you ran into is that we exist for 12 years, and a lot of the stuff that exists today, things like Terraform, things like Pulumi, things like, I don't know, a multi-cluster load balancer, just didn't exist back then. So we were like, I said cloud hipsters or something to you, where we had to, we did everything before it was like a cool product. So, so yeah, one of the things we wanted to talk about is why we do the things at Philips Hue like we do. So at Philips Hue we use Pulumi to manage our infrastructure. Who here has heard of Pulumi? Yes, cool. So who here knows about Terraform? Some more hands. Cool. So a quick overview of what those two things are is they allow you to describe your infrastructure as code. So you want a Google Cloud project, you write down resource Google Cloud project basically, and then it will make sure that the resource exists in the cloud. But something else it does, which is also quite cool, is that it knows about changes that happen. So not automatically, but I can probably do that. So if somebody would were to change the name of the project or something, and the code says it should have name A, but somebody changed it to name B, if you try to check it again, it sees, oh, it has the incorrect name, so it reverts it back to the correct one, basically. So you have your single source of truth. So together with your Git, you have entire Git history of why changes were made, which is really powerful, especially when your project exists for 10 years. And you want to know why somebody changed this weird setting in this load balancer or something, which if you change it, everything breaks. Just a weird example. Don't think we actually have. We do have that. So the reason we use Pulumi is because, well, it's really powerful because it allows you to write code like with TypeScript or with C# or Go, and it allows you to use all the features of the language itself. So you can write for loops, you can write really complex code, which is also a bit dangerous because letting you write bad code will make sure that at one point bad code will be written. Yeah, something that's also really powerful about it is that it's a bit easier to import existing resources. So Terraform 1.5, which recently came out, did something about that. But with Pulumi, it's a lot easier to import existing resources because since you have the entire TypeScript API, for example, you can just fetch resources from the internet, do some matching, and then like dynamically generate the resources that you actually need, which is something we use a lot. Like we use Auth0 as our identity provider, and a while back we actually migrated that from this tool we made ourselves, which was this imperative TypeScript script that you just run and it changes some settings, but not everything, because we don't know what every setting is, to Pulumi. And yeah, I think it was quite neat, but I buy it because I wrote it myself. Yeah, and we also, for other projects, use Terraform. So we recently did something with that. And what's really nice about that is because it's a lot simpler. I would recommend it for like when you start your project with infrastructure as code in mind. Yeah. I'm missing something. I think that's it. So here's a quick example of some infrastructure as code to get a bit of a feeling for the difference between something like Terraform and Pulumi. So here you have a storage bucket with an object in it in Terraform, and on the right it's in Pulumi. So it's almost the same, but it allows you to, like, in TypeScript, write a for loop, which reads a directory cursively and all those kind of things, which are also possible in Terraform, but it is a bit different. So our takeaways are, after having successfully migrated an existing project that were entirely ClickOps by just doing things in the web UI, to Pulumi, also successfully migrating self-developed infrastructure as code, like I just said, Auth0, which is now, it's called ZeroCool. Yeah, and creating new projects with Terraform, they're quite complex from the beginning, like from start with keeping in mind that we had to allow multiple environments to be made and need to be really agile because there were a lot of changes being made, a lot of decision making in the last moment. So things we learned is that it was worth it to start with infrastructure as code. At the beginning of that project I'm referring to, we had a bit of a discussion about, do we want to just like wing it and write some bash scripts and just write down in a document what we did, or do we want to do actual infrastructure as code with Terraform? We decided to do infrastructure as code, and it really helped us out later when we ran into some troubles and we found out, oh, it's just documented here, this in here the Git history. That was really nice. But something we could have improved was that we need to layer it more. There's a lot of good documentation about this, where you structure your infrastructure as code in layers, where the things that are most static you start with, and then the more dynamic it gets, how more often it changes, you separate those. And you can also really nicely make components, both in Pulumi and in Terraform. Terraform has modules for this. Pulumi uses custom components that you can compose together out of existing resources. Something we also did a lot was ClickOpsing and then importing, because sometimes, for example, the Google Cloud Load Balancer. If you create a load balancer, it doesn't simply create a load balancer. It creates your forwarding rules, your proxies, your URL maps, I don't know, static IPs, backend services, and it's really nice to just create it to the UI and then later import it with all the correct settings in place. Yeah, and unfortunately not everything can be done through infrastructure as code. Some authorization stuff often, credentials, sometimes gets a bit more difficult, but that's fine. You can only go so far. Like at one point there has to be some simple bash script to like bootstrap everything. And then a bit about how we deploy all this stuff. So we use Pulumi to deploy and bootstrap our clusters. It's responsible for deploying Argo CD, which is what we use for managing our deployments, keeping everything in sync with our GitOps repository. But before our applications end up there, a lot of stuff happens. So we have 4 environments we have 3 environments and then production, where it ends up. But before it gets there, there's a long way to go through layers of testing, building. So each component in our cloud works mostly the same way. So they all have some metadata that describes, oh, this is I don't know, this is some API proxy. It has these Docker images, which are built using Go, which is really cool, or just a normal Docker image, supporting certain platforms, architectures. What else can it do? Yeah, things like that. And we also can define some parameters for each environment. You would normally do this through like customize or something like that. But again, this was written 10 years ago. Well, like 2015, 16, I guess,
Yeah,
when we
something
moved
like
to
that.
Kubernetes. Yeah. So things like Helm or Customize didn't really exist or really popular back then. So we have our own system for syncing our things between different environments and managing the configuration. These YAML templates and configuration actually live in the same repositories as the components itself. Oh, also really cool fun fact. Back in the day, before we actually had Kubernetes, we used to deploy things to Trello. So we had our own integrations that if you like drag a card from like staging to acceptance, it would trigger a webhook to deploy to the correct environment, and you could actually do rollbacks and things like that. I don't think we both weren't there. No. Maybe,
I've heard about it at all times.
yeah, fun to hear about. Now we have a simple pipeline, which is not actually simple, which is responsible for validating manifest, testing, building the artifacts that you saw in the metadata file, and creating a deployment metadata file listing things like the git SHA or deployment information, which then gets synced to our GitOps repository, from which point Argo CD will take over. It watches the repository, it uses our own custom tooling. Again, we didn't have Kustomize or Helm, so we have the UCLI. Deployment is also used to go through the UCLI, but it's a lot more stripped down now. It just renders templates using our own template engine. Yeah, then it syncs, it has some hooks to notify our Slack, to, I don't know, reflect status back to GitHub. So we have some other triggers for that. And then your application is live and is being watched. And I think that's already my bit.
Yes.
Now we go back to you.
Are there any questions
Yeah, good one.
at this point?
How does Pulumi manage the state of a deployment similar to Terraform? Like you can store it locally or put it on S3 or wherever you want to put it.
Yeah, we use a Google Cloud Storage bucket for our backend, same as you would do with Terraform.
And so Pulumi uses Terraform providers in the background.
Yeah,
So
there's some sort of connector that's like more marshals things between Pulumi and Terraform providers, so it uses all those things out. Yeah. Oh, you were first, I think?
Marvin, you mentioned more than 42K requests per second.
yes,
Is it coincidence that it's 42?
it's more than 42.
Exactly.
It was a nice number to say it's more than.
Well, what is it on average?
I'm not actually sure what's an average. So it's pretty, we have seasonality in it. As you can imagine, it's a lighting product. So usually around 8 p.m. in the evening, we have the peak traffic, and then during the day it calms down a bit.
Things like every hour. People have a lot of automations that run like
What about on Christmas?
Christmas is fun fact. We usually have a bit more standby. It died down a bit, but there were times where Christmas is time also when everybody gets like new bridge or new lights under their Christmas tree. So there's a lot of setup and a lot more usage happening around Christmas time.
I think you were first.
Well, actually, based on what you just said there, do you find you get like awkward peaks on the hours because of automation? When people set up a natural automation is going to be on an hour and a half hour, right?
I think it kind of evens out a bit. So it's a worldwide product.
Okay.
So that kind of evens it out. There's no really like every hour we see a massive peak. It's usually more in the evenings. You notice that the traffic gets like more than 5 times as heavy as during the day.
Just two questions. One, how frequently do you do deployments, and which tool do you use for the pipeline's failure monitoring?
So the first part of the question, like multiple times a day, depending on which service. Sometimes we have busier days than others. What was your second part of the question?
So which tool do you use for the pipeline failures monitoring and debugging?
Oh, monitoring pipeline failures. Yeah, we just use GitHub.
Yeah, it's all GitHub. So all our pipelines are in GitHub
Oh
Actions.
well, actually, we have Datadog dashboards for Nike automated tests.
What's the name again?
Datadog dashboards
Okay,
for the display or test failure rates.
cool. Thanks.
Good.
Yeah, I will talk a bit about how we make sure it's actually reliable for detecting the oops and DevOps. So first of all, who here is familiar with Site Reliability Engineering, or SRE? Time bit. So I will actually start this then with a bit of an introduction into SRE. It originated at Google, and what Google says about SRE is SRE is what you get when you treat operations as if it is a software problem. So if you're familiar with DevOps, this sounds pretty familiar, right? You treat your operations. If you want to know more, SRE.google is the site where Google writes down everything they do for SRE. So Google is a leader in SRE. It originated at Google, and they have a lot of really good documentation. about it, and I will try to explain it a bit shortly. But I'm not the complete expert. That's guys at Google who actually write the books about it. So everything with operations starts with the question: how reliable do you want your software to be? So, are there any guesses? How reliable would you want your software to be?
100%.
That's a good one, because 100% is the wrong reliability target for basically anything. So this is what Google says about, or what SRE basically describes about reliability. 100% reliability means that nothing can go wrong. Nowhere in the chain. It's almost impossible to achieve. And usually your users don't really benefit from 100% reliability. What Google says about this, or what I've kind of rephrased a bit. So what I think and what Google kind of says about this is you want to give yourself achievable reliability target. What Google actually says about this is you want to give or you want to decide the reliability target together with the business and decide it based on the user impact. So what will your users notice? At what point will your users start to get annoyed? At what point will they leave to competitors? At what point will they stop using your services? Those are the kind of things where you want to base your reliability target on. And that almost never comes out to 100%. Because if you have a retry button in an app, for example, the user is probably fine with every once in a while pressing a retry button if something fails. So it doesn't have to be 100% reliable as long as your user experience is still good enough. And this, so at some point you define it, and you can define this target in an SLO or a service level objective. So that's basically an objective you set yourself. This is how reliable I want my service to be. And what that then gives you is room for unavailability. And this is where in SRE also, and just like DevOps, there's SRE teams do both the operations and the development. So that availability is called an error budget, and that's what you can spend on getting maximum feature velocity. So if you don't have to be 100% reliable, if you're already 100% reliable, you can spend more time in becoming more reliable. That doesn't make sense. Just start writing new features and start developing new stuff, and at some point it will probably break. And that's fine, because you can be unreliable for a bit. But if it goes down, of course, too much, then you want to spend some time getting your reliability back up. So that's in very short what Google, what SRE a bit defines. And this is a great framework for deciding how much time we want to spend on operations and how much time we want to spend actually developing cool new features. Then, of course, the second part of that is, how do you know the reliability? Because you can say, I want my service to be 99.9% reliable, but how do you actually know it? Google, again, SRE guys have basically laid out 4 golden signals, or what they call the 4 golden signals, that for most services define, based on these signals, you can define reliability. So these are latency. So latency, I think, is pretty straightforward. How long does an HTTP request take? Or if you're not doing web services, how long does a certain action take? And what you actually want to do for latency is you want to divide it up. So you want to have your latency about good requests and your latency on bad requests. Because if you combine it all, you can have, for example, HTTP 500, something is going wrong, that might return in like a millisecond because some connection isn't available. So then you think, oh, my latency is fine, but actually it's not fine. Your error latency is really good, but your normal latency might be higher. The second one is traffic. So this is if you talk about requests, for example, but it can also be other things. So if you're looking at databases, it might be the amount of transactions you get. Yeah, that's a really good signal to see what's the health of your service and how much load does your service receive. And you get errors. I think that's pretty explanatory. How many times does something go wrong in your service? Also really important to know. And then the last one is saturation. And saturation means how full is your service. And that can be, for example, how much memory is used, how much CPU is used. For databases, how much disk space is left, for example. So that's really an indicating of how it gives you an indication of how much headroom do you have left. So if you look at your traffic, for example, and you combine it a bit with saturation, you can really see how much more traffic can I receive based on the amount of saturation I see with my current traffic. So if you have all these four, then usually you can tell something about how reliable your service is. Is that clear for everyone? See some pictures being taken. So if you want to read more about it, esri.google. Yes?
How do you detect the amount of errors in it?
I will come back to that. So wait a little bit. How do you measure it? So that's the next part. Knowing what you want to measure is fine, but how do you actually do that? We use Datadog for this, which is a monitoring tool. And Datadog really combines everything. I'll talk a little bit more about that later, but you'll see a lot of Datadog graphs now. So let's start with the easiest one, which is saturation. So these are some screenshots of dashboards of some of our services. And here you can really see, so we have CPU usage, for example, we have memory, we have throttling, which is also a really interesting one. If you want to talk about saturation, how much your application is being throttled in a Kubernetes environment is really also a good indicator. And also things like the amount of replicas and the maximum number of replicas. Because in Kubernetes you can define how much replicas of this service do I want to have. And if you reach, if you're at the top of that, then it can deploy more. So that's also a really good indicator of how saturated is it. So then there's three more things left. That's latency, traffic, and errors. And for that, you can all you could all do that with tracing. Who knows about tracing? Who uses tracing? Cool. So tracing gives you latency, traffic, and I put traffic in between brackets because tracing does add some overhead, so you might not want to trace everything, which then takes away from your traffic signals. And error visibility. And what it does is it helps you understand the full path of a request. So certainly in our case, we have a lot of microservices, and a request doesn't end up in one service. It goes through multiple services. And it interacts with a lot of things. And tracing can give you the full path of that request. So it can give you insight into what's actually causing latency. So if you see higher latency, and you can see what's actually causing the latency. So this is, for example, one of our traces. That error. So you can see at the end, you see the exclamation point that says error. So you can see here that it came in at some point. There's a little bit missing. I think that's the load balancer that's not being picked up here. But you can see we do some authorization, we do rate limiting, we do some internal calls. You can see data store calls in there, and then some other functions. And then you see we do a GET request at some point, which errors out. So you have a full overview of your entire request, what it did and how long everything took. So if you want to get started with this, OpenTelemetry is basically the standard everyone is moving towards. So OpenTelemetry.io, that's a really good starting point, and it's supported in many tools. So this screenshot you see here is Google Cloud Tracing, but also Datadog, and I think a lot of cloud providers have views for tracing and support for that, or you have open source tools like Jaeger, which you can host and run yourself. So that's something about tracing. And I actually want to give you a bit of an example of what we found with tracing. So we had defined a bit of a latency as low, and our latency looked like this. So this is one of the graphs we have with latency. You can see it's pretty spiky. And it also sometimes goes over the 200 milliseconds, which we didn't really like. So it was kind of burning into our SLO. So what we did is we looked at some of the traces of the longer requests, and they looked like this. So who here can tell me, who here can spot in this trace what the actual issue might be? And I explained it to you, so, so you're out. Do we have good guesses here?
Data store is lagging.
Google data.
Data store is lagging?
Yeah.
Yeah, that's a good one.
Something seems to be blocking, I think. Or
Yeah. So-
non-concurrency.
The interesting part is you can indeed see the entire data store. So this is the internal data store client, which adds traces and spans. But the even more interesting part is these little dots here. Those are events that happen. So what you can see here is that at some point the data store client received basically the request. So here it said, it told the data store client go look something up, and then actually started doing that here. So there's a gap in between where the data store client didn't send out the request yet to the data store, and then at the end, of course, it gets a response. So what we found, what our estimation of this was, is, all right, so it's waiting for something. The most logical thing a client can be waiting for is probably a connection. So let's Google data store client connections. We found out there was an option to set a connection pool, which you can increase the amount of connections the client keeps to the data store, which it can use to communicate to the data store. So we increased that number basically, and then we released it, and you can see that our latency really flattened out a bit, is less spiky. So this is really an example of something that we could find pretty easily with tracing and with knowing how to read traces. Also, if you were to look at this latency, certainly end to end, and try and figure out what's actually causing the spikiness, it's really difficult and it will take you a lot of time. While here we could very easily find it. Any questions until this point? So I've already shown you some screenshots of Datadog. That's the tool we use. Is anyone else here using Datadog? A little bit? Cool, nice. So Datadog is a cloud monitoring solution. So it's basically an entire suite where you can see how your applications are doing. And it combines a lot of things, including metrics, traces, logs, and more. Today, a lot of stuff into one place, which is really powerful. So why do we actually use this instead of, for example, using the Google Cloud monitoring solutions? It gives easy dashboarding. So we have over 100,000 custom metrics that tell us what our applications are doing and if everything is going right. And in Datadog, it's really easy to graph those out and create dashboards with all those metrics. And it can correlate between metrics. So this is a really cool part about Datadog. You can say, I see something going wrong here. Maybe you see a latency spike, for example. You can select that time frame, and Datadog will find in all your other metrics and graphs you have if there's something else that looks like that spike or something else that changed in that time frame. And it has surface visibility and automatic issue detection, so it can actually detect issues for you. So you don't have to look at the dashboards yourself, it can detect it for you. So what does that look like? Well, this is an example of what happens when you have a lot of data into Datadog. This is a page of one of our services, and it's a bit difficult to read, but here you can see the last deployment and when it was deployed. You can see we have no errors, we have 2 SLOs which are okay. We have no incidents. You can see the amount of requests and the latency of those requests. So this came from the traces we emit to Datadog, so it can generate metrics of those. It can also generate error metrics of those, so we have no errors. And it can also actually see errors in logs, for example, if those are correlated to the surface. And you can also see for your application how much time is spent by downstream services. Well, Togold is our most downstream service, so it's only spending time on itself. But for other clients, you can see that. And at the top, you see Watchdog Insights, which has like a monitor going off. And this one is about, so we have 2 clusters, one in the US and one in the EU, but we have one database in the EU. So this monitor is nicely telling us, hey, on your other cluster, the latency for your data store access layer is about, what's mentioned here, I think 3 times as high or 6 times as high. So it can detect based on tags and based on data you emit to it if there's anything changing. So this is one we expect because requests from the US just take longer to reach your database. But it can also, for example, detect if you deploy a new version and one of your APIs got slower in that new version, it will also detect that here. And it can even, if you tag your API with what's happening, so if you have an API that, for example, either does get or get requests and update something in the database, it can actually filter those 2 out and say, oh, only the ones that update something in the database have become slow. So that's really powerful. And Datadog knows a lot more about the system for us, so it can also show you what exactly is going on. So the whole saturation part is also handled by Datadog. So here you can see at the point I took the screenshot, we were using 2 cores for the service with 12 pods running, and there's also tabs for like CPU, memory. Basically, you get one view of all your important monitoring data, and based on all this data, you can then define monitor SLOs and monitors. So this is a monitor for one of our services. It sends us Slack messages and emails and Opsgenie messages if one of our services goes down. And then we have SLO defined on that also that tracks how much time we've been down. Well, in the past, now says a week or primary 30 days. This service hasn't been down, so that's really good. We can start developing a lot on it, and it can go down a bit. It has 21 minutes of error budget left, so we can develop 21 minutes of downtime into it. Yeah, so that's a bit of what you can do in Datadog and why we use it. But it's not something you have to use. Datadog is also quite expensive. But a lot of these things that you can do in Datadog, you can also do in other services. And actually, a lot of cloud providers, if you're in the cloud, you probably already have tools available to you to create dashboards, and you probably already have metrics about all your services, because most cloud providers already have those built in. So what did we learn throughout the years with regards to SRE and DevOps? Well, first of all, start tracing your requests. It really helped us out when we started doing it. We really learned a lot about the services, and we noticed how easy it was to then find out what is going wrong. I think at this point, 90% of our services have tracing built in, but yeah, at some point when we had a couple of services with tracing, we really noticed that on the other services we were basically flying blind. We could see something going on, but we didn't know it exactly. And at some point we also had gaps in our tracing. So one service would forward the request, and the other service had tracing yet, and we could see like this gap of blankness in between where the request did something, but we didn't know what it did. So the second thing we learned is a lot of frameworks have metrics built in. So gRPC, Go, .NET, Spring, you name it, it probably already has a lot of metrics built in for free that you can get out of it. And if you're in the cloud, then it's even nicer because then everything you run and you already have the metrics available to you. You probably don't need to do anything to get most of the metrics.
You mentioned Datadog is really expensive. I've never looked at the pricing, but presumably there's some sort of retention time on this tracing data. Like you keep it for 7 days, 14 days. Do you know how long you keep it around for usually?
I think for us it's 14 days. You can do a lot. So Datadog is more expensive than having it, for example, in your cloud provider. It does give you a lot. So there's of course always trade-offs, but you can tweak Datadog a lot. So you can set retentions, and that all increases or decreases how much you pay to Datadog. So you can decide how much do you actually send to Datadog. So for tracing, for example, on our scale, we don't trace every request. We trace a small percentage of requests because it adds a lot of overhead, and emitting traces for 24 or 42,000 requests a second also costs a lot. So you don't want to do that. I don't know if that answers your question. Cool. So the third one is create dashboards for your metrics. I think this is where usually it's really easy to do, but sometimes it's missing. It's just creating one overview where you can get a full view of how is my service doing, and where you can quickly basically open it every morning and see, yeah, everything went fine yesterday evening. The fourth thing is combine metrics, traces, and monitoring in one place. So for us, that's Datadog. We used to have it split up a bit. So you could see the screenshots were still from Google Cloud Trace. Nowadays we also have that in Datadog. But having everything in one place, it makes it really easy for the entire team to see what's going on and to know where to look. Because we have a lot of services. Not everyone knows most services the best, basically. Some services haven't been touched for the past year. So if you have a new team member who comes on and at some point sees a monitor go off, he already knows he can just go to Datadog and find the dashboard for that service and see all the metrics for that service, because it's all in one place. And last but not least, define some SLOs. Just do it. We started with it. We certainly don't have SLOs for everything. But defining those really helps you decide on how much time do I want to spend on getting the service running better. And it also helps you in communicating when something goes wrong. Because if I tell you that we had 300,000 errors in a day, that sounds like a lot. But if I then tell you that it was 0.1% of our requests, then it's less. So that really helps in communicating and also deciding for yourself how fast do I need to run if I see something going wrong. And you can, for us most of the time, we didn't really look at the whole part of how much is the consumer impacted, and discussing that with the business, you can probably make estimated guesses how reliable do you want a certain service to be. So that was it. Are you interested in doing any of this? I think you can talk to Maurice. We might have some places available. We are both interested to learn more about what you guys are doing, and if you have anything we can learn from. So thank you very much. Any questions?
Yes, I asked you a question about measuring errors, but I didn't get an answer.
Yeah.
Because some errors are more, have a higher priority to solve than others?
Yeah, so part of defining an error is saying what's actually an error. So in HTTP you have 200 OK, but you could also have a 404 not found. And you could say a 404 is an error, but in a lot of cases a 404 might not even be an error. If a user navigates to a page that doesn't exist, or if a user gets some data that has been deleted and then gets a 404, then that's not an error. So the first thing about what errors do you have is defining what's actually an error. That's the difficult part, and that differentiates between services, and there's no single answer for it, sadly. And after that, so within SRE, you just measure, so against SLO, for example, you can say, I have this many good requests, I have this many bad requests, and you bundle all your bad requests. Now I do understand that there might be some errors which are probably worse than other ones. And usually if you measure also, if you have your latencies, your traffic and your saturation combined, and then mostly latency and traffic, that will figure out which errors are actually more important, and then the other ones will start going on too. If your database is down, for example, your latency might also be spiking. Yeah, that gives you a full view into your errors. In the end, what it basically for us boils down to is we have a lot of monitors set up, and we trigger those based on the errors, and then somebody takes a look at it and decides, is this actually worth investigating or not? But usually you will see the errors that actually are important because they will impact more. There's more impact on the errors that are actually important.
It really didn't answer my question, but I understand it. But if an error is not important, why do you test it?
So one error might not be important, but if it happens 100 or for 50% of the requests, for example, then it might very well be important. So that's the differentiating factor. How much is that error happening? And that's what you define in those SLOs, is you say it's fine to have some errors occur, as long as it doesn't impact too much. And once those errors start piling up and there's more and more errors, and it's happening for a lot of users, that's the point where we say, now we need to do something about it.
Are you able to talk types of errors to see, like what is the trend line? Like, are they happening frequently, or it's a one-time error?
Yeah, so we have a lot of metrics on our requests, and usually by error code, so we can see what kind of errors we are getting. The SLOs we define are more general, so they say we know which response codes we defined as OK. That isn't an error. And then we have some that we did define as an error, and if those start happening too frequently, at that point the SLO will stop burning. And SLOs have something called a burn rate, which is basically how fast is your SLO going down. So if you have a 30-day SLO, then it might be fine to have, let's say, 50k requests error. But if that all happens within 10 or 20 minutes, your burn rate will start dropping massively, and you can already be notified beforehand, so, hey, it's happening so frequently that if this continues, then you won't reach your SLO target by the end of the month. So that's how you can more easily see which errors happen more frequently, and do I need to take action on that?
Yeah, thank you.
No, it depends on per service. So we have some services which we trace 100% of the requests, some which we trace only 0.01% of the requests. It depends on traffic a bit, how much we want visibility into that service. And we are looking at, so with OpenTelemetry, you can do some fancy stuff. For example, tail-based sampling, which is something we're looking into, and that means you can say, so instead of this, normally you decide on the forehand, you say, I want to trace 1% of my requests, and then when a request comes in, basically 1% can tag, hey, you need to be traced. With tail-based sampling, you can say, I want to trace requests with, for example, error. So I want 1% of the requests and 100% of the requests that error. So it keeps all the requests in memory, so it adds some overhead, but can be interesting for some services. So that's something we're looking into. We don't have that yet. But there's a lot of different ways to decide how much you want to trace.
And you can also create your own samplers, like a leaky bucket sampler, for example, where if you have only one request every hour, but sometimes you get 1,000 in an hour. You also you collect basically everything until a certain point, and then you start the bucket starts overflowing, and then you just stop for like an hour or shorter.
Is it possible to trace all requests for employees?
I guess you could, if you have like an incoming header.
You can make decisions based on headers, for example. The dangerous part is, so you can actually start tracing from even a client device. The dangerous part about that is that the client can also use that maliciously, of course. So that's not something we do. But you can make, you can set up it, you can add tags, you can make decisions based on the request to say if it gets traced or not. Actually, what I didn't mention was really powerful as well is that if you add the trace IDs to the logs as well, you can even see the logs from the traces, and usually in the logs the logs you keep probably always, unless you also sample those. But then, you can still, if the request wasn't traced, so that you don't have the information available of all the spans exactly, you can still find all the logs for a certain request.
First, what was your the worst incident this year? Can we start?
I think so. We had a little bit of downtime with actually API groups. So Eslo, you saw that's now. We had a little bit less uptime. Now there was an issue in there with some configuration that caused it to crash sometimes. At some point we run multiple instances, but a couple of times it happens where all the instances crashed at the same time. I think that was one that took the most time also to figure out why it was crashing.
Do you track time to acknowledge and time to mitigate?
Yeah. It's automatically tracked in Datadog.
Okay.
So I have a question on deployment of the new features. So after release to prod, do you do some type of warranty and monitor the impact on the systems? And how quickly can you roll back the features?
So our deployment works based on pull requests. So the GitOps repo is basically a single source of truth for what's running in the cluster. And if you make changes, automatically the pull request gets opened. And we merge that after the approvals, and that releases it. So reverting it is really easy. That's just reverting the pull request, and then it might take, it depends on the service, how many instances are running, how long it takes to roll back.
Sometimes you need to go forward.
Or sometimes you need to go forward. Usually we always are able to roll back at least once, because you have both versions running besides each other, so they always need to be compatible. We have a lot of automated monitoring set up, so we get notified often when something, or if we release something and it really goes wrong, we get notified of that. Usually we also open the dashboard, so we have, for every application or every service we have a dashboard that contains the most important metrics for that service. And usually whenever we merge a PR for a service to release it, we also open that dashboard just to follow how it rolls out, and if we see anything out of the ordinary.
And do you take into account adoption of the new features? Because it still it needs time to notify end users that something been rolled out, right? And when they start actually using it more actively, that make impact on the performance.
So we have two kind of things. So we have a lot of our changes are actually just immediately picked up because we have just a lot of traffic, and whenever we change something in one of the services that receives that traffic, it is used instantly. Some parts we do have, basically we release APIs, for example, that need to be implemented by other teams. For those, the moment they start rolling out and they start using that, we usually, so we already have the metrics, we add the metrics whenever the service, or we build it. So when they start rolling out, we keep an eye on the metrics just to see if that happens normally. So recently we had the camera launch for VQ, so they now have secure cameras. We also have some APIs that support that, so we create a specific dashboard for every API related to that whole system to basically keep an eye on if they are going correctly or if they're working correctly whenever they start getting used.
Okay, cool, thanks.
Cool. Thanks.